And we should be live.
Okay,
Istvan, the floor is yours to introduce the guests and stuff.
okay, thank you. Welcome everybody. I think this is the 31st Data Science Leuven meetup, and it's me again who is hosting, and that's because we have a technical problem with Lean. Hopefully, she will come back later. So we have three guests today. The first one is Sander Bruin from Data Roots, followed by Dieter Castel of Zinjoy, and then the third guy, I can hardly read his name, it's Istvan Heino or something from GFK, who will be the last speaker for tonight. Well, since I didn't prepare anything, I think Lean had a few other things to say, but we'll have to skip that. So I propose that we immediately, there is Lean in the dark. I don't know
Hello.
what that means. So Lean, do you want to officially announce some?
Yeah, sure. Wait, give me a second to share my slides here.
Okay.
All right, here we go. So let's hope I won't have any more computer trouble as we go along with this meetup. But welcome everyone to our 31st Data Science meetup on YouTube yet again. We once again have an amazing lineup of 3 speakers, like you're used to. The first one of them will be Sam. He'll be talking about how to deploy a ready-to-go data lake in 30 minutes on Azure. And he works for Data Roots, a company that we know pretty well here in the community because they're one of the really big success stories, I guess, from Leuven in the data science space. So it's really nice to have Sam here with us today. Second in our lineup is Dieter. He just joined Zenjoy, another really cool Leuven-based company. And he'll be talking to us about Julia, the new kid on the block in statistical programming. So Julia is a programming language, and it's one that I've been interested in for a long time, but never really had the time to dive into. So I'm really excited to have Dieter here with us today. And lastly, we'll have our very own Istvan, who'll be talking about what he actually does for a living, which, I mean, I've known Istvan for like about 3 years and I still haven't figured that out. So I'm really excited to hear him speak here at our meetup tonight. And then I also have a message for you guys. We love this meetup deeply. And we want to say thank you for still being here with us. It's been a hard year for everyone. It's been a hard year for meetups especially. So thank you for being here, listening to us, attending. We also wanted to let you know that we need you to stay involved. We need you to recommend speakers, join our meetups on YouTube, use the comment sections, do whatever you wish, reach out to us. This is us. We're very active on Twitter. We're also on Facebook, but does anyone use that anymore? I'm not sure. We're very active on Meetup as well. You can reach us by email. The face-to-face option is a little harder, but otherwise we're good. And also wanted to say this is the best meetup on earth. So that's it for me. Now let's share some slides here, and then some. You go ahead. Floor is yours.
All right, thank you, Lee. So I'm Sam de Bruin. I'm a data engineer at Data Roots since March this year. So when the coronavirus started to pop up in Belgium. Previously, I was technical lead and architect in mobile application development. So not really involved with big data and data science, but I worked a lot with Azure for approximately 5 years now, because we had to build a lot of backends for our applications and things like that. You can reach me at sam@dataroots.io, and I'm also on Twitter. So today I'll talk about how we can easily deploy a data lake on Azure in less than 30 minutes, or even less. 30 minutes is like the maximum, the upper limit. Why is it? Because Data Roots built a Terraform module, and this is a complete package that deploys the data lake for you without a lot of effort. required. It should save you a couple of weeks of time when you use this module. First, I'm going to talk about all the components that are part of our data lake network. We'll start with the architecture, the logical architecture. So this is the one that we use at DataRoots for most of our projects. This is like a template that you can reuse all the time. Every data lake has a place where the data is ingested. This can be batch events or streaming. So it depends on what kind of data and how often the data goes into the data lake. The data goes into the raw data lake container, so the first layer in our data lake, and from there you have several layers that built on top of it. The first one is a cleanse layer, so you first clean the data. The important thing there is in the raw data is literally untouched, like the source. And in cleansed, we try to make sure, like for example, that numbers are treated as integers or double values, things like that, and not as strings, that we remove invalid values from certain columns. And then we go to the curated layer where we have a standardized model of our data, where we have transformed layer in a way that it's easy to use for every consumer of data lake. From there, we can go to the integrated layer. There we have separate versions of our data depending on the applications that want to consume them. So, for example, a machine learning project could use this, and maybe it doesn't need all the different collections that we have inside our data lake. So in that case, you would tailor it specifically for the projects. And then at the end, you have the aggregated layer where we have all the results that we want to present in analytics tools, reporting, or dashboards. So these 5 layers are what we usually set up at customers when we are building data lakes. To decide on the components, we use 3 different aspects to evaluate what we're going to use: functionality, performance, and pricing. We prefer managed services because they require less maintenance from us, and in the future as well. They offer usually higher SLAs, and they offer a lot of options for availability and redundancy, which is very important. I suppose nobody wants to lose their data, and scalability is also very important. And this is something that we can benefit from most often with managed services. The first tool that we're using is Azure Data Factory. Azure Data Factory is like Azure's managed service for data pipeline orchestration. You can compare it with something like Airflow. We use it for ELT with a lowercase t because we extract and load data from our sources, but we don't really do a lot of transformations with it. We prefer to keep the data as is, and the only transformation that we usually you do with Data Factory is like the format. For example, from CSV files to Parquet, without touching the data itself, but just saving it in a different format. In this way, we can use it for data ingestion. Data Factory offers tons of connectors for different sources out of the box, so they don't require a lot of configuration. At one of our customers, we use this to extract data from an on-premise SAP instance, and it was really easy to set up compared to other options that were available to us. You can use it for orchestration, monitoring, and versioning for data pipelines. It stores all the configuration as code optionally, it's not required. So you can benefit from all the benefits that you can get with infrastructure as code. So all the data pipelines are in Git. It allows for easier collaboration. You can see why certain changes are made and when and who made them. Things like that are very useful in bigger teams. We use data lake storage to store our data. This is the most obvious option on Azure. It has very high upper limits, and you can even contact Azure if you need to increase them. The next service that we're using is Azure Databricks. As a data engineer, I often prefer to work with Spark, and Databricks is a managed Spark in the cloud. They offer it as a standalone service, but Azure also integrated in their cloud. Spark, if you don't know it, is a popular tool for in-memory data processing. You can set up clusters. So in Azure, that would be clusters of VMs that you have inside your subscription. And spread out the data and let them do the calculations in a distributed way, so that it's easier to work with bigger big data. And then Databricks offers some extra features on top of that. It's not just Spark. They have support for Jupyter notebooks, and you can also version them with Git. So once again, a lot of benefits there. And we'll use it for data cleansing and transformation in our data lake. And then we have Azure Synapse Analytics. Right now, it might be confusing because Azure has 3 products with similar names. So they have Azure Synapse Analytics right now, which is the new name of what was previously known as Azure SQL Data Warehouse. Azure also introduced a new service called Azure Synapse Analytics Workspace. This is in preview, and this offers basically the same features as the SQL Data Warehouse. They also have serverless SQL, so you don't have to pay for the compute all the time, but only when you use it. They also have serverless Spark, which has the same benefits. And it even includes everything that is available inside Data Factory. So in the future, this will be like the go-to tool for data engineers on Azure. And right now it's still in preview, so that's why it's not included in our data lake, in our module. And then there's a third one, Azure Synapse Link, which is a new tool that allows you to do a live database analysis. So for example, on Cosmos DB or something like that. We will be using Azure Synapse Analytics as an integration endpoint. So that is the best way to connect other applications to our data lake. This is the 4th layer inside the data lake. And because it's just SQL, then a lot of applications can obviously work with that. And then the final service that we will be using is Power BI. It's not really a cloud service right now. You can publish dashboards in the cloud, but you have to use a desktop tool mainly for editing them. But it's like the go-to tool in the Microsoft stack to build dashboards. And Power BI has a lot of advantages in the way that can connect to all the different services I mentioned before. So the data lake design looks something like this. This is based on documentation, Microsoft documentation on their website. They provide some architecture patterns that I recommend to use. And you can see that it's very similar to the thing that I just talked about. So they use Azure Data Factory to ingest the data. And from there, they can transform the data with Azure Databricks. You can go directly to Azure Synapse Analytics as well if you want. And all of this can be orchestrated with Azure Data Factory as well. In the end, you can use something like Azure Cosmos DB, I suppose, because it's a database with a REST service included, so that you don't have to build any APIs. So you can use Data Factory to just copy the data to Cosmos DB as well. Now, setting up all these components can require a lot of effort because you have to set them up one by one. You have to configure them. Most projects would also have like a development environment, a staging environment, production environment, or even more. So if you want to build something that you can easily scale and configure and don't have to worry about, if, for example, someone deletes something accidentally, you can use infrastructure as code. Infrastructure as code means that you define everything that is in your clouds as code. So literally program, well, not really program because they're configuration files, to literally type out what you want to create in the cloud and how you want to connect and configure them. And this is what we did for you. So we use Terraform. Terraform is like the go-to tool for infrastructure as code. It supports a lot of different clouds, Azure being one of them, but you can also use AWS, Google Cloud, and they even have Alibaba Cloud and things like that. Terraform comes with two main components, I'd say. They have providers. A provider connects the tool to a cloud or a service. So this can be Azure, this can be Databricks. Yeah, they're more like connectors. And then modules are building blocks for your infrastructure. So we have one big module for a data lake that we will provide, and that will deploy the whole data lake for you. And it has configuration out of the box and all the credentials. So it saves a lot of time because when you run the command Terraform apply, this deploys everything. So it's pre-configured, and if you want, you can also extend it with your own resources, which we'll do during the demo. The module that we will be using is open source and available on GitHub. It has some documentation. We also have automated testing to make sure that it keeps working. You never know that something is deprecated, and in that case, you would get a warning, and we can adjust the module so that it's easy to work with again. If you have any issues and suggestions, you can also report on there. That means it's time for a small demo. The thing about deploying things in the cloud is that it can take a while. I said under 30 minutes because in some cases it takes about 30 minutes to deploy the whole module. And even when I did this presentation a couple of months ago, in the start of the Corona crisis, it didn't completely work because the Azure data center was at capacity. But I have tested it a couple of times today, and we won't have that issue today. So let me go to another screen. You can type Terraform code with any tool that you would like. So your codes, Atom, IntelliJ. I prefer to use IntelliJ right now because it offers syntax highlighting and things like that. And that's always super cool to work with, right? This is a new Terraform project I created for this presentation. So Terraform looks a bit like JSON. If you've never seen it, then I hope that the syntax is not really too confusing. I think it's very easy to start with. I even hadn't used Terraform 1 year ago, and now I'm very comfortable in using it. What does this mean, all this configuration? Well, this means that we're providing that we're setting up the Azure provider with one resource group, and our module is using a lot of Databricks. So we also provide a Databricks workspace. In previous versions of our module, we deploy Databricks also for you, but we noticed that it's not always easy to work with because the dependencies between different components can sometimes still be a little icky in Terraform. So in this case, we recommend that you provide the Databricks workspace yourself. So you need these 4 lines to deploy it to Azure. This tells Terraform that can connect to Databricks itself as a service. And then finally, what I have here is a module. Also another one that is open source on GitHub. And this creates a service principal. So all I had to do is also give it a name and the validity of the service principal. So this one will expire after 1 year. So what I have to do now is use the command Terraform init. It will set up my project in my directory. It will download everything that it needs to know about the providers. I have some other files here as well, but they're not really useful. So an empty file called locals, a variable, something that you can use inside Terraform to make things variable. In this case, we're deploying to EastUS2 region, but I can change this, or you can change this in the command line because it's a variable. And then versions, because I want to work with Terraform 0.13 with the latest Azure provider, and same for Databricks. So Terraform init downloaded those two providers. And if I now use Terraform plan, Terraform will calculate what it needs to deploy to make this available on the cloud. So if I go to my Azure subscription, or my resource groups, so you can see the resource groups I have in there right now. There's one called the Leuven Meetup, but that's not the one that I used inside IntelliJ. So if I go back, you see the name of the resource group was the Leuven. But the resource group is not there yet, so it's time to create it. Terraform plan is saying it has to create 7 resources, and it creates a search principal, it creates the resource group, the Databricks workspace as well, and some helper resources. For example, something to keep track of the expiration of the search principal. Terraform plan has a parameter called out. You can use to say where it should store the plan. And then with command Terraform apply, I can apply the plan that Terraform created for me, and it will start creating these resources in the cloud. So that's what it says at the end. With Terraform apply TF plan. Now it's creating them. So this might take a while, obviously. A resource group doesn't take too long, so it says in the logs created after 2 seconds, but the Databricks workspace usually takes a while. Now, we don't have a data lake yet, obviously. We only have the Databricks workspace, and that's not very useful without any data. So what do we have to do to add our data lake in there? Well, it's very simple. Like it says in the README of the module, you have to add the configuration for the module. So what is this saying? It's saying the name of the module where you can find it. So it's the one that Databricks provides for you, the version of it. The name of your data lake, so it's going to be called Leuven DL. And then some parameters like the location, the name of the resource group, the service principal credentials that we just created. Service principal, if you have never used Azure, then you probably have never heard of it, but it's some kind of service account that applications can use to talk to each other and exchange credentials. It's like a username and password, but for applications or services. Then storage application tells it how to replicate the data so that it can recover in case of failures. I chose the cheapest one. That's obviously in real data lakes, you use something that is distributed over multiple data centers. And then there are a lot of more parameters, like really a lot that you can configure. So these are configuration options that we provided for you. One of them is provision and signups. So if you set this to false, which is not by default, and this will make sure it doesn't deploy the data warehouse because it's the most expensive component, and it also takes a while to deploy. I decided to put it to false today. So Terraform is deploying our configuration. If I now go to Azure and you refresh it, you see the new resource group, and inside of it you can find the Databricks workspace. If I now wait until it says it's finished deploying it, and you Terraform apply again, and it would also deploy the data lake. Now we don't have that much time today, so I already did this in other projects. So I followed the same steps. So I started with Terraform init, then Terraform plan to create a plan. In this case, it would create a lot more than before. It would create a Cosmos DB account, it would create a SQL container called metadata. This is something that we use inside the data lake to store metadata about all the collections that we have, all the data sets. Then it would also create a data factory, and it would link the data factory to the storage account, which is created right here. So all of these things are configured and connected to each other in the module. And as you can see, deployed it all successfully, 26 added. So if I go to the other resource group, this was the other one that I created before, then we should see the different resources in there. So right now there are only 4. But if you configure everything in the module, then you really a lot more. You can configure a key vault to store all credentials. You can configure log analytics workspaces. So you just have to provide some IDs of existing resources to connect it to, and then the data lake will make use of this and log all executions of your pipelines, for example, to a dashboard or something like that. An example of this is, for example, Azure Data Factory is already connected to the data lake storage. You don't have to do that yourself anymore. So all of this should make working with Azure and setting up data lakes there a lot easier. Maybe I can quickly go over some questions if we have any. Let's see. Do you have any questions in the chat? I don't think so right now.
Hey, there are some questions.
Okay.
They're not popping up in the chat yet, but I saw them on YouTube at least. Jesse Blum, or Bloom, sorry if I pronounced your name correctly. I think he has two questions. First, he says data lake or lakehouse, and then he says lots of opinions represented by that tech stack like Azure, Terraform, Synapse, ADF, Databricks. What were the rationales behind the choices, pros and cons? Question mark.
Yeah, that's good. The echo is back, Chris. Thank you. Yeah, so it's really a module that we built at Data, which is an opinionated data lake. The components were evaluated by ourselves, and we think this is a stack that is easy to work with and to set up new data pipelines, and they also go really well together. We work together with Microsoft on this, actually. If you go to the Azure Marketplace, you can find a module there as well. And we got tips from Microsoft on how to structure it and architect it. The pros and cons of the services, well, basically the 3 things that I showed in the slides. So the pricing was important. We don't want to pay a lot for our data lake when you're not doing a lot with it. So pay-per use is something that we always try to go for. In this case, I think the only component which will cost you something if you're not using it is the data lake warehouse, so Azure Synapse Analytics. So that's why you also have an option to disable it. All of the components are built by use. So if you don't transform, process, cleanse any data, then you don't have to pay anything. Well, if you store some data, obviously you have to pay for the storage. And they also offer very good availability. There are other options for each component there. For example, if you want to use Spark, you can set it up yourself on like a Kubernetes cluster. You can also use Azure AG Insight, which also offers Spark. But then one of the advantages of Databricks is that it allows for easier auto-scaling and auto-termination. Once again, something that is useful for scalability as well as for pricing. And yeah, I could go over every component in detail on why we chose for that one instead of other similar components. For example, we talked about possibility of using Airflow. Well, there is no real advantage for storage. And Science Analytics, it depends on the use. You can also go for a SQL database, or not use it at all, or use Cosmos DB. It really depends on what the customer needs, but I think in most cases, SQL interface is something that you can easily work with. I hope that answers the question.
Yeah, I'll unmute myself to quickly ask a question again, and then I'll mute myself again, because apparently I call some
I can help if you want, Chris.
I can help if you want, Chris. Okay, yeah, go for it. I'll remove myself.
Okay, so I think our next question was Bart, who asked if you use Terraform remote state, or how do you typically set this up?
Yeah, we always use remote states. So in the demo, I obviously didn't go through all of it, but we usually set up multiple environments and then CI/CD pipelines to deploy our infrastructure, because a module is a good start and it deploys most of what you need, but every specific project obviously requires specific services for it. And you can keep on building and extending your Terraform infrastructure, and then it's important to have it in CI/CD so that it's not just stored on your colleague's computer, and when he goes on holiday, then nobody can deploy any infrastructure anymore.
Maybe for the other viewers, you can maybe first explain what remote state is in like a couple of words.
So in this case, in the demo, if you look at the files I have here, you'll see that I have the files from the project, but there is also a special file called Terraform DF states. And if you look at that file, it lists all the resources that are currently deployed on Azure, also with secret keys and things like that. So it's something that you should try to secure somewhere. But Terraform needs this to compare the current state to what you want to deploy, to make the plan and to see what is new, what has changed, things like that. But if you store it on your local machine, then you are the only person who can deploy these projects. If you use Terraform remote states and store it somewhere in the cloud, for example, and then everyone who has access to that remote state can deploy this project and update it and add new resources, delete existing resources. So if there's a project on Azure like this data lake, then we store it on Azure Storage. If it's on AWS, then you can store it in an S3 bucket, something like that. And
right. Sorry, go ahead.
No, that was all.
Okay, I think we have one more question and we have like a little bit of time left. Peter is asking, he's saying that he has little experience with data lake, but he wonders how often do you really build these data lakes?
Well, for the projects we do at Data Roots, a data lake is very useful to get started with big data projects. So, for example, one of the customers that is using this today is the Puratos Group. There we started with building the data lake because the data lake will really hold all the data that can be used for the machine learning project that we have there. We first did a proof of concept, but the proof of concept used some CSV files locally. And the next step was to get all the data that you can use inside the machine learning, because you want to connect it to actual data and make sure that the model is producing actual results and not based on sample data. The data lake is on the base of all future projects that we can do at that customer, for example. So we started with with a project to help them in deciding which customers they should contact, And yeah, to improve the sales, now they're using it to help with better deciding on ingredients for their products that they have. And all of this can easily be added onto the data lake. So because they have a lot of data in there already, they can just use new machine learning projects connected to the data sources and benefits from the advantages. Otherwise, I'd have to look for the data in some database somewhere and then link it with data in some other environment and connect to an API and things like that. The data lake is really the central location that has everything that you need and the source of truth.
All right. We received one more question from Peter Jan, but I'm going to have to ask you to ask that question some other time. Some is very easy to reach on Twitter, trust me, but I'm sure he'll be able to answer your emails or LinkedIn messages as well. Some, thank you so much for doing this. Like, where's my banner? Here's my banner. Oh, there we go. Thank you for being here with us today. I thought it was super interesting. And then I'm going to switch over to Dieter's presentation here. Yep, there we are. Unmute you. All right, Dieter, go ahead.
Thank you, Lien. I will be doing my talk about Julia. Really, this is a 101 introduction to Julia, and I have done a much more extensive presentation on it at the statistical department of the UGent, but I will shorten my demos and my talk, so no worries. You might see like the number here, like it won't be 50 slides, don't worry there. So let's get started then. So this is a short outline. I won't do everything of this, but normally I like to be interactive, but now it's a bit difficult, so let's skip this already. But this is something relevant though. In my presentation, I highlighted all the Julia packages in this nice pink color. So if you see some package name like that, you know, like, okay, if I want to use something in Julia, you probably can use that package. For example, CSV is a very nice performant CSV file reader and writer in Julia. I'll skip this as well. So who am I? Okay, I studied computer science at the Leuven, and currently I'm doing software development at Senjoy. And basically, I picked up Julia in my free time and trying to doodle with some images and have some fun in that. And because Julia is really well suited for statistical programming, like I got talking and then I was allowed to give that talk. And here are some of my experiments. There are much more of them. If you like to see more, just ping me on Twitter. So now, who's Julia, or rather, what is Julia? Because actually, I had to change the name of this talk. It was it used to be New Girl on the Block, but someone from the community reached out to me in a really friendly way, and he mentioned like, yeah, we really want to be extremely inclusive, so maybe it's not a good idea to like personify Julia. So maybe that's not a good name. And I was okay. I want to adhere to the community standards, and so I decided for this talk to change the title. But Julia is a programming language like many before them, but then again, not. It is dynamic, which really means that much like Python, you can choose not to type your code, but it has a really powerful typing system, and that will also help you. But it's well suited for both small scripts and large, complex and high performance projects. And that's really like one of the things I like about it. Like the usability is one thing, and then the performance is just off the hook. Like it rivals with native native performance, and that's something really powerful to have in like what feels to be a scripting language, really. It's powered by LLVM, the compiler infrastructure project, and this one also powers Rust, for example. You might know that. It's fully open source, like and also very transparent. Like what I mean by that is you can from day one, and I will show you in a minute in the demo, dive into the code if you want to, in the native Julia code, but as well in like any third-party written code, and also, and that links to the usability I mentioned earlier. Julia has a system of environments that make it reproducible. Like you can really indicate, okay, I want this and this version of this package, and not that and that, and it will just run out of the box on any machine just with that file. And that's another problem that several other languages known as dependency hell have, and that's something they try to solve as well. You will, if you dig into this, you will certainly appreciate the commands activate and instantiate in the REPL. And that brings me actually to the first demo. I'll show this slide. Keep this in mind, because actually I will be in all my demos switching back and forth between these four modes, and I'll show how that works right away. So here we have the Julia REPL. You just started by typing Julia, and then the programming terminal interface comes up. If you start here, like I show here in the slide, you have the green bubble, and you start in the Julia shell. Of course, here you can type, like, for example, a variable and a string. Doesn't matter. Okay, that's a simple variable. Nothing special here. But say you want to get some help, like I don't know how to get started. Okay, you just press question mark and enter, and right away off the bat you have some nice information here. And what it mentions here, for example, is that if you have a question about any function, just type question mark and anything, and then, for example, println gives you a nice output of, like, okay, you want to print a line, here's how you do that, and some examples. And we can do that, of course, or use A. We set A, so okay, this is rather uninteresting. Let me see what I have in. Okay, you also see here what I was typing. I pressed tab a lot, and this is actually a nice feature of the REPL. You can autocomplete pretty much everything. Like you can autocomplete if I press it here. You have the function name, really, but also if you have a string, and it is smart enough to know, like, these are all files here. It's smart enough to know, okay, yeah, you might want a file here. Let's give you a file. This is nice. What else is nice is that it, next to like the regular Julia prompt, you also have a shell and a package manager. The package manager you can reach by pressing like this button. It's the closing bracket, and you see like the bluish color indicates that you are now in the package manager. And if you want to add something, for example, add Pluto. Is it add? Yes, should do something. It's probably just loading. Okay, this doesn't work. That's a stack trace. I probably. Okay.
Hey, Dieter. I'm sorry to disrupt your talk, but it seems I can only see half of your screen. Do other
What?
people also have this issue? Yeah, I can only see part of your slides.
Part of my slides? Okay.
Yeah, do you have the management window open somewhere? Can you?
The management window?
I mean our call. Okay, now it's back.
Is it better if I just put it in the middle?
Yeah,
Because
it appears to be better. Yeah.
thing is,
Okay.
if
there
I'm
were other
showing the-
people also mentioning the issue. This is better. Yes.
Okay. Yeah, I hope
Okay.
that.
I will mute myself, and if the issue comes back, I will interrupt you again. I'm so sorry, but it was such a shame
Okay.
that we couldn't see your screen. Continue,
fine.
please.
Okay, so yeah, I was showing some, adding some package, but I guess I mistyped something there, and that's why it didn't work. Anyway, it's again here. If you're in the package and want help, you can get all the help you want just by typing question mark. Much like if you're here and you type, you come into the help. You also have it for the package manager. So let me finish what I started here. What should I else? Okay, I talked about auto-completion. I showed you the package manager. And then Unicode. Unicode is very well supported actually in Julia, unlike in some other languages. But they go far with this. For example, if you have this function, you can filter something. For example, let's say you want to filter a value that is in some array, for example, 1, 2, 3. And then let's filter all the values from 1 to 10. Here you also, this is an example of a range in Julia that just works. And like you might have not noticed in the way I typed it, but what I did was I pressed backslash and then in, and I pressed tab, and that replaced that command with the Unicode character. And actually, this for me is a nice feature because if you're writing some mathematical algorithm, the Julia code really comes extremely close to what is the pseudocode or the mathematical formulation, and this is again a nice usability feature of Julia.
Hey, Dieter. I'm
Yeah.
sorry. We're having the same issue again.
Okay, but
I have no idea. You have this keyboard overlay thing?
yes,
Maybe we
I
can,
do.
if I don't know, maybe we can shut that down and see if it helps. I have no idea.
Yes, I can shut it down, but that's okay.
I have no idea. It appears that I can see your screen in full again. Okay. Please continue.
I'll
Sorry.
continue. This is a difficult. Okay, so let's continue with some slides then. Like, just mention it if you can't see them, but I'm not sure what else is happening there. Okay, so I showed this one, the first thing. Here is some more Julia code. Like, I like functional programming. It supports all kinds of paradigms, but functional is the way I like it. And here is a typical like functional approach. Like you map like the f variable to whatever comes after it. You can do it with multiple arguments as well. And like another thing is Julia has this nice built-in tools for manipulating any type of data really. And of course, map is also available for the functional programmers among you. This is really a simple function, just reading some files and filtering the PNG extension from them. Okay, and this yeah, I then use this to write some inversion scripts because I like the dark themes here. This I will skip. I'll get back to some more demos. Yeah, I'll just go back to the demo screen. Okay. So what I didn't show yet, but I showed it on the slide, is here that you also have the shell built in. If you just want to do something real quickly, like move a file or anything, you can just press well, this with the keyboard thingy gone. You can see it now, but the semicolon. And if you press semicolon, you just can type any command line command. And this shows me again, like, okay, what other demos I can show you. So the get files one, I'll include that one and see what gives. So let's see. Okay, yeah, this is another nice thing. Say you see some codes and you're not sure, like, okay, what actually, where is this implemented? It happens often. You don't know all of the code base of some project. So what you can do in Julia, and I already prepared this, but you can set your custom editor however you like. I like Vim. And what you can do is, for example, if I have a simple command here, print this string, what you get is it will open your editor for you, and there you are. You're at a line where exactly that command is written down. And this is straight to the main source code of Julia, but it works perfectly for any third-party package as well. Like, and this is so useful because, and that's something for another demo. I will discuss it in a bit if I still have time, actually. Yeah, dynamic dispatch is maybe I just go straight to that. Note that the add means that it's a macro in Julia, and macros are used for meta programming. And again, a really powerful system in Julia for meta programming. Then I will have the Meetup one. That's the dynamic dispatch. So dynamic dispatch, what do I mean by that? I'll just show you what is in the file. I just defined two functions. One with an optional, but here I explicitly stated it, type argument for the argument, the function argument, and one with a string argument. Note it has the exact same name. So if I do this now, and I give some just integer value, of course it will return like this string. No surprises there. And again, the same with a string. For example, enjoy. That's my current employer. Here you go. And this is, I mean, this is basic, you might think, but it is actually really powerful. And turns out that you don't need inheritance if you have this. Like, you can solve pretty much any problem just using this dynamic dispatch, and really powerful. So like it also enables like the compiler to do nice optimizations to for example, yeah, go to another platform that has better performance for whatever you are doing. I haven't tried running code on GPUs, but I heard it's pretty nice in Julia. For example, many more things to show, too little time to show them all. So I'll try to wrap up, I guess. Interoperability, I would love to cover it, but like feel free to ask me for the presentation. I can send you or some more information. But the gist of it is that you can call other languages pretty much like natively, and it just works out of the box. I made several wrappers for example, Python programs, and it just works. It's very nice. So even if you like some library in Python, you don't have to give it up per se. just give Julia a try and see what you like about it. And so yeah, that concludes my talk. I'm ready for some questions if there are any.
All right, thank you so much, Dieter. The issue was actually fixed after the keyboard thing shut down. I have no idea what caused it or why it caused it.
Okay.
But
Good to know.
I'm glad I was able to see your slides because it was super interesting. We have a first question from Jos. He's asking, what does Julia offer that the others don't? Why should I learn Julia over any of the other languages?
Well, it really depends what other languages you should consider. If I mean, Julia is built in mind to be and fast and easy to learn. Like the entry bar is similar to like Python. If you want to start programming, go for Julia, I would say. And again, if you want to do performance things, again, go for Julia. So I asked this around on Twitter, and someone reverse asked this me like, why would you choose anything else? And I was like, yeah, I'm convinced. So, yeah, there is of course for every new language there's new interesting reasons to use it or not to use it. But Julia is for me the first language really that clicked. Like the usability and the performance, like those combined, it's rare, really, I think.
Mm-hmm. I think with that you already answered Cam's question as well. He asked if it was the future for machine learning and data science, and you seem pretty convinced that it is.
Yes.
Yeah.
Although I did some research for this talk as well, and some people mentioned like, okay, yeah, for certain things it's not there yet. But keep in mind, like Julia is only 8 years old. Like it's for a programming language that's extremely young, and already there are like impressive achievements. Like they're building a complete climate model in Julia. I mean, that's something that needs that performance really well. Like for me, it's indicative. Like, okay, Julia will be important, and it seems to be well liked as well. If I read about it, if I asked around, like, and again, the community is so inclusive. It's really nice. I like it.
We have loads of questions for you. I think people have been really excited about Julia. Let's see. Maybe let's take an easier question first. I think Christophe is asking if Julia is being used for any serious projects that you know of, like big companies, tech companies that are using it. So you mentioned the climate modeling use case. Do you have any other use cases in mind?
I know of a publication in Nature that Julia was as well. I don't know the exact topic on that. I would have to look that up. But I think, yeah, it might be early days because, for example, I was on a job hunt not too recently, and in Leuven I couldn't yet find a company really digging Julia. But I think it's bound to happen anytime soon, and I plan to introduce it in Zenjoy certainly. But first I'll have to like get to know Zenjoy a bit, I guess.
That's great. I hope your employers are watching. Everyone, Julia.
Yes, exactly, guys. Come on, give it a shot.
The community agrees. So I mean,
yeah. Guess so.
Someone is asking specifically about interoperability. It's Michael with R.
Yes. Very good question. And actually, I would love to show you, but currently I haven't installed R here. But I have some RCall demo that I did actually for the statisticians at the UGent, actually, again, the same thing there. It's the interoperability is really nice. even for RCal, I think it's probably even better than for Python, because you also have it interactively. They wrapped like the interactive REPL of Julia, so that you can actually call R from that's like similar to how you here have the shell, like I showed you. You then have an R prompt. So if you know, like, okay, I can do this really easily in R, just do it, and then you can store it in a Julia variable and get along with it. Like, and for that, I got a couple other questions, like there isn't yet a good alternative for RStudio. Like, I think, like, because RStudio is really focused on usability, but I can't imagine, like, with a community like Julia, it will come, and I mean, R has a lead of like I don't know how many years, so I'm sure that will be fixed as well. Like,
I think I've heard like whispers of people working on stuff that you had the IPy widgets project a while ago, which was supposed to kind of recreate RStudio, and then they were continuing that into the Julia community.
That's nice. I didn't know that. Thanks, Lee.
I'll send you some proper links after your talk. So then maybe the tougher question from Ronnie. He's asking what are the 3 main advantages of Julia compared to Python, and you cannot mention performance, he says.
Okay, for Python specifically, I always hated the white space thingy. Like, for Python, you have to put exactly 4 spaces, for example, or exactly 1 tab. For Julia doesn't have this. That's for me already a winner. I mean, like, we're living in 2020. Let's not. It's hard for me to answer that, but I think I like the. Of course, like, Python has so much more tools still, but with the interoperability this well, I can't say that it's much of an issue anymore. I mean,
how do you feel about tools in Julia, actually? Because I'm an avid Python user, and I like data frames and scikit-learn, and everything is so great. What do you have in Julia?
Well, you have data frames for one. Like that's a package.
All right, that's 90% of my job. That's okay.
Yeah, there you go. No, I'm no statistician myself, so like for that aspect, there are many great learning resources. I actually have some here in the end of my, like, the docs are excellent. You also have Julia Stats, which is like the community for statistics in Julia, and then you also have several like GitHub notebooks where you can learn all the things you need to know for data science. And additionally, I would love to mention, like, there is a really nice new notebook written, I think, completely in Julia. It's called Pluto. I tried to install it, but I think I mistyped something. And that actually is something they are rethinking that as well. And I saw already a YouTube course using that to learn image processing, and like with a guy from 3 Blue 1 Brown, I think. And I mean, that looked awesome, like a Julia course on image processing with Julia and the new Pluto notebook. Certainly check that out if you're into like that kind of stuff. I think it's very nice.
Thanks. Well, final question for you today, Dieter, is a question concerning multi-threading. You have the global interpreter lock, which everyone despises in Python. Parallel processing in Julia. Does it work? How does it work?
Good question. I haven't actually gotten around to like doing a lot of parallel stuff. Like I mentioned, like I guess for a lot of parallel things, you would like GPUs and things like that. There are certainly libraries for that. I know of several. There are bindings with CUDA, if you like that, and I mean Julia really runs from a Raspberry Pi to a supercluster and anything in between. So although I haven't tried it myself, I'm pretty confident that yes, it will run really nice parallel jobs, and you won't have to worry about the locking thing.
Yeah,
I guess.
at least it doesn't have the global interpreter lock. I think that's all we all needed to hear. Okay, thank you so much for doing
My pleasure.
Let's give you like a really big virtual applause. And then I'm going to switch over to Istvan here. There you are, Istvan.
Thank you, Leen. Shall I start?
And there are your slides. Go ahead, Istvan.
Okay. So good evening, everybody. Let me switch to my presentation here. Here we are. So my name is Istvan Heinal, and I work for GFK. And one thing that I have noticed is when I talk to folks, especially when I talk to data scientists, and I tell them that I work for GFK, somehow they seem to confuse it with GSK. And I don't know why. I don't really see the similarity there. But so for the record, GFK is a market research company, while GSK is a pharmaceutical company. Although I will admit that there is at least one relationship between the two, and that's Paul Smith, who is a data scientist at GSK, happens to be the co-organizer of our sister Meetup Data Science Leuven, and I'm one of the co-organizers of Data Science Leuven, so there you go. It's a fun little game. You should try it yourself. It's called The 6 Degrees of Separation to Paul Smith. And which brings me to the next thing. Is when I then actually say, okay, it's not GSK, but it is GFK, the market research company. A lot of data scientists will be a little bit disappointed. They will say, okay, so you deal with whether washing powder is popular or not, or they start moaning about opinion polls being wrong again, or they say, well, it's all very nice and well, but it's not rooted in science. It's all fluffy stuff. And the more sophisticated ones will say, but does market research still matter now that we have big data? And so for the next 20 minutes or so, I would like to, let's say, give a general and broad overview of what market research is from a data science perspective. So in a certain sense, this presentation will be, let's say, a follow-up on Philippe Daguerre's talk last month. So Philip was going into the nitty-gritty details of one particular application that he has done. What I will do is something completely different. I will touch here and there some things that are happening in market research that might be interesting or worthwhile to know. And hopefully I will, after those 20 minutes, convince you that market research or the market research industry is a nice place to be for a data scientist, and that it has a rich past and hopefully also a bright future. So let's start with the past. And a question that I ask quite often when I talk on subjects like this is, what was the first private company to ever order a computer? And well, obviously with the whole COVID thing, we cannot do it interactively, but let's say that generally speaking, people are mentioning banks or retailers or manufacturers, but those were not the first. The first company to ever, or private company, I should say, was the Nielsen company. And the Nielsen is the largest market researcher still today. So the story is, in a nutshell, that the son of the founder of Nielsen worked with computers, with a mainframe computer during his military service. So after the war, he went to his father and he said, basically, Dad, can I have some money because I want to buy a mainframe computer, or something like that. And so that's what they did. So they ordered one together, I think, with the insurance company. But then what happened is that by the time it had to be delivered, the government, the American government, said that they needed it, I guess, for the Cold War. So they were the first to order it, but not the first to use. So what did they do with this? Well, they had, let's say, at that time, two important services. One was measuring radio audiences, and later that became also measuring television audiences. So when you hear people talk about Nielsen ratings, that's where it comes from. The other service was a retail service where basically they were sampling stores, and they would send in auditors that would measure stocks and go through the purchases and then derive the sales to the consumer based on that. And so for that, they used a computer pretty early on. Maybe another thing, and now we're in the 60s now, in the 60s of the last century. Nielsen UK was one of the first companies to adopt the PL1 programming language. And for those of you who are a little bit older, you will know that PL1 stands for Programming Language 1. And for instance, the SAS system, the first versions of it, were programmed in PL1. And actually some of the syntax is really, some of the SAS syntax is really inspired by PL1. So now you know why you hate it. But then came the 80s, and then, and this is very ugly English, but apparently that's how you need to translate de wet van de remmende voorsprong. In English, apparently they say the law of the handicap of the head start. I didn't know that, but I looked it up. So what happened is that they were doing their business, they were doing fine, but in the meantime, the retailers had replaced their mechanic cash registers. They had changed them into more electronic POS systems. So the guys from IRI said, hey, but hold on, maybe we can use that data to compete with Nielsen. And that's exactly what they did. And actually they created quite a lot of difficult times for Nielsen when they did that. Now, there are two important features here. One is, if you think about technology that was available in the 80s, we're talking about a large amount of data. It's not comparable with what we do today. But if you think about the technology that was available, it was quite large. And then secondly, IRI was actually using the data for another reason than it was actually collected for. Those two features might remind you of something, because some people use this as the definition of big data. So with a little bit of a stretch, you could say that IRI and the Nielsen later were doing big data avant la lettre. Okay, so and then we're now to the early 2000s. And what we saw then is machine learning in production systems. So some market research companies used algorithms such as WinNow in their production systems for quite a long time. I assume that by now they have switched to something more performant, but they've been doing that for quite a long time. So WIN now, for those of you who don't know it, it's an early generation neural network similar to the perceptron algorithm. And again, this might not sound very spectacular, but this is right after the second AI winter. So I think they were pretty close to the ball. And then maybe, and now I'm switching closer and closer to the current situation. If you look at the world of machine learning and deep learning, what you will see is that one of the hot topics, I guess, last year and the year before was explainability. So people suddenly realized that there's more than just having the highest accuracy. Clients also wanted to know, yes, but can you explain what the model is actually doing? And you have many solutions for that, like Lime. Another one that is quite popular is based on Shapley value. And effectively, Shapley value is something which has been very popular in market research for many decades. An example here is, if you look at the quite popular SHAP package in Python, if you look at its documentation, you will see that it has a whole bunch of spanking new papers from 2015 or younger. There's only one old paper in there, which is from the year 2001, which was written by Stan Lipovetsky and Mike Conklin, and those are two statisticians from GFK, actually. And maybe Mike is even listening tonight. I know that he was last month, so you never know. So that's Shapley value. Maybe another thing that is worthwhile mentioning, and that is, well, before data scientists, we had what we call statisticians. And market research companies in the previous century were, let's say, quite important employers for statisticians. That's something that we tend to forget. At the same time, I must say that there was quite a wide, and there still is actually quite a wide discrepancy between the statistics in the field and what academic statisticians are doing. So it still surprises me today that there are academic statisticians that are, let's say, not really familiar with statistical techniques that are quite popular in market research, such as conjoint analysis, turf analysis, and association rule mining. I have a few slides on them, and I'll come back to them if I have enough time, but there are some other things that I want to show that are, let's say, more important things from the present, because that's where we are now. And if we look at the present situation, we must admit that market research is not leading anymore, but it is catching up. So I think in general, market research was quite late in adopting big data environments. It was quite late in adopting deep learning, but it is getting there. Same thing, I think, for the cloud as well. There are a couple of large market research companies that are now that have moved their complete production systems to the cloud, but there's still there are some other companies that are not there yet. Personally, I also don't see the killer application in the marketing or in the market research sector yet, but that might change. And another thing, if you look at the current situation, I think that market research is struggling competing with non-marketing research or market research companies, both small and large. So if you look at the smaller companies, what you see is that there are some smaller companies, I should say, that are offering excellent NLP or visualization or data engineering services. And so some companies that, let's say, 20 or 30 years ago would come to us will now go to these companies. And I don't think we really know what kind of answer we need to give, or whether we have to give an answer at all. And then the other side, the larger non-marketing or non-market research companies that are, let's say, that we're struggling with are the Googles and the Facebooks and the Amazons of the world. So these companies are coming more and more in the, let's say, sphere of market research. And again, there we don't really know yet how to react on that. A very important element of market research is survey-based market research. So questionnaires. And one of the reasons why market research is struggling there is because of the decreasing response rates. If you look at that over 50 years, it's quite impressive, the decrease. Another element is let's say, random sampling in a survey context has become much harder than it used to be for various reasons. And so as a consequence of that, there is a decreased quality because of those 2 points, or in fact, I should say a perceived decreased quality. And I will later on explain why it is perceived. The other thing is that our clients very often think that we are less relevant because of big data and other sources. And that's also something that I will talk about later, why that is not necessarily the case. Okay, so my personal view on this is that the survey is not that yet. And I know that survey is much more than political opinion polls, but we've just had the elections in the US, so I still want to say a few things on political opinion polls. But to be very clear, GfK Belgium is not doing political opinion polls, so I have no interest there. And also, when people ask me what I think about doing political opinion polling in Belgium, my advice is always don't do it, because there's no money to be made. And you never win a reputation with it, you just lose one. So if you're smart, you don't do it. Having said that, I still think that political opinion polls are getting too much heat. And one of the reasons, I guess, is a memory effect. So people tend to remember when polls are wrong, like, for instance, the US elections of 2016, the Brexit polls, and there are some other examples. But when they are right, it's not discussed at all, let alone that it is remembered. For example, who remembers the first tour of the 2017 polls in the French elections? Nobody. The polls were very good at that point. There's also another thing that plays, and that is pundits, journalists, political commentators. They take those polls, they interpret the polls very selectively, and then they blame the polls afterwards. The Brexit is a very clear example of that. If you look objectively to the numbers, they were not that bad, or the predictions were not that bad, but the way it was presented in the press was probably different than what it should have been. So that's about opinion polls. So what is my take on this whole thing? Well, my answer would be look at the science. And 2 years ago, there was a publication in Nature Human Behavior, where they looked at polls after the Second World War until now in 45 countries. So we're talking about 30,000 polls approximately and they looked at the quality. And their conclusion was that, contrary to conventional wisdom, the recent performance of polls has not been outside of the ordinary. So obviously, it's also possible that in the past they were bad as well. But nonetheless, it's important to realize that if you actually objectively look at these things, that the quality is not decreasing. And this is surprising. Why? Because doing an opinion poll today is much, much more difficult than it was 60 years ago or something. So apparently, somehow, they have found methods to, let's say, improve it. And I think that's also where I see the role of data scientists. So I see a role there to improve the quality of survey research and combine survey research with other sources. There is a clear task for data scientists there. So one of the things that I would like to point out is a method that is getting a lot of attention lately, and it's called MRP. I don't know whether many people are familiar with MRP, but MRP stands for multi-level regression and post-stratification, and it comes from Andrew Gelman and colleagues. It's about 20 years old now, but it's gaining a lot of traction lately. I guess partially because it's now relatively easy to estimate models like that with a piece of software which is called STAN. And STAN is a probabilistic programming language for statistical inference. And by the way, you can integrate STAN with R and with Python, and also with Julia. If anybody feels like experimenting in that area. So I will not go into the detail of what the system or what the methodology does, but let's say the post-stratification part is used to adjust or to correct for selection bias, and the multi-level regression is used for small area estimation. And the combination of these two seems to give promising results. And one of the papers that created quite a lot of fuss in that area is a paper where in the International Journal of Forecasting, where they reported about forecasting elections in a very biased sample or panel, I should say, of Xbox users. So Xbox users, they're much younger than the general population, and they are more male than the general population, but yet with such an extreme form of non-representativity, in combination with MRP, they were able to get some decent results. Lynn, you will have to help me on the time here. I see that I'm talking for 22 minutes. Do I still have some time?
You have some time, just because it's here.
So okay, good. So then I'll go over these slides as well. So the current trend is not so much inventing new techniques, but now what I see people doing in market research is taking existing techniques and applying them to a market research setting. Typical examples of that are NLP, Bayesian networks. And so in the next slides, I want to show you an example of where we use something which it's not that new, but let's say it was new because now you had a software to do it on a larger scale. And we have applied that to a classic old market research problem of shopping basket data. And it's called non-negative matrix factorization. That's, by the way, joint work with Dr. Caroline van Damme, who is now a data scientist at D'Ieteren. The only thing you need to look at is the very first formula there. And the X that you see there is just your data matrix. So you have N baskets and P products. And if a product is in a basket, you will get a value of 1. Otherwise, you will get a value of 0. And that matrix, that will obviously be a sparse matrix, is then approximated by, let's say, 2 component matrices that will reveal the structure that is in those baskets. And here you'll see a heat map of those matrices. And what you will notice here, for instance, my data matrix, or the transpose of my data matrix here, the X, it looks like completely red, and red is in this case 0, and 1 is white, and yellow in between. It looks completely 0, but that's just because it's a sparse matrix. There's here and there some small white dots in there, you just can't see it. But this matrix, if you decompose it in those 2 components there, you get some of the structure out of it. And okay, I cannot go through all the details, but here is some output, and unfortunately it's in Dutch. So my apologies if you don't speak Dutch. But what you can see here is that this factorization somehow seems to find the structure that is in those baskets. Like the first component clearly is fruits and vegetables. The third component is something closer to drinks and things like that. So the problem here is not so much the statistics or the computation. That's in fact quite easy. The problem is more, how do I build a product from that clients are willing to pay for? I guess that's probably more the challenge today than it was in the past. So that's non-negative matrix factorization. We also did a visualization, and I specifically added that slide because a couple of months ago we had Lode Nachtergale from Colruyt here, who was not a fan of TCNE. But I told him that we had some nice results, and this is actually the thing that I was referring to. So every dot on this chart or plot is a basket, and the coloring is based on the retailer where the basket is coming from. And what you can clearly see here is that baskets from Aldi and Lidl are clearly separated from all the other ones, which is obvious in a certain sense, because they are, especially Lidl, are having different barcodes. But nonetheless, it is clearly separated. And there's also some other structuring in there. For instance, and I don't know whether you can see my cursor here. Yes, hopefully. So if you move from here to here, what you will see is that here I have Colruyt, and here at the top I have the Leuven. So with a little stretch of the imagination, you can see an axis here, which is going from the hard discounters over to the soft discounters, and then at the end moving to the more premium retailers. So again, there's something in there, but it's a matter of turning that into a successful product. This one I will skip, and which brings me to the future. And again, you will have to stop me, Lien. So,
how much longer do you need this time?
It's only a couple of slides, but I can stop at any time you want to. But basically, just a couple of things that I want to make sure that I get to say is that what the future will bring, I don't know, but I have asked around. And so some people are saying, well, response will decrease even more, so we will see less survey research. I am not convinced that that is true. But okay, some people are saying that. Some other people are saying integration of different data sources, already important today, will be even more important tomorrow. Then somebody else said a big challenge will be the data collection and the technology for data collection, more specifically because the two will be very often not sitting with a market research company, but will be sitting with partners. And that will create organization and operational challenges, which will affect data science as well. And effectively, we've also seen that with GFK, that is indeed creating a lot of problems. The one from Media Markets, that one I will skip. You can read it later. And also my rant about COVID studies, I will skip that one as well. We'll keep that for Twitter. But let's say, personally, I predict the glorious return of the sample. And I want to end with two quotes. One is from Professor De Kimpe, and I will not read out all his accolades here, but he's basically a very important guy in, let's say, marketing analytics. He was asked to write an overview paper on big data analytics. And he wrote, so the abundance of secondary data may lead one to abandon primary data collection efforts, even though many important organizational issues faced by retail manager can best be addressed with targeted survey data. So my point here is, if Marnik De Kimpe, Professor De Kimpe said so, then we probably should take notice. The other and final quote is from Sandy Pentland, and he's professor at MIT, has been in Davos discussing GDPR. He's the godfather of Google Glass and what have you. So he's the real deal, right? He was in Brussels last year, and that was at a conference organized by Eurostat and the European Commission. He was asked, can you give some advice to practitioners of official statistics when it comes to big data? And his answer was, and this is really literally, his answer was, look at Nielsen in the US. They use a panel of only 3,000 families to validate and calibrate the different digital data sources they have. This is the way official statistics needs to go. So there again, I would say, if Sandy Pentland says so, we probably should take notice. So I am pretty confident that we have not seen the end of the sample yet. And with that, I want to thank you for your attention, and I give the word back to Leuven.
All right, thank you for that, Istvan. Those of you that have been around since the beginning of our meetup heard me say that I was super excited to finally find out what Istvan actually does for a living, what his job is. And I'm not sure if I got any closer to the answer today. I think it's something to do with Twitter rants, a lot of Twitter rants. I think the best description of his job would be AI historian, something like that.
No, that's just my age. That's a different thing.
But we have a bunch of questions for you, Istvan. So
Okay,
let's
go ahead.
Address them really quickly. Vaslem is asking, why was market research so late to get into using big data techniques, do you think? And he also offers a potential explanation. Maybe it's because the data acquisition is performed in a closed market fashion and it's highly competitive. What do you think?
Yeah, that might be. They thought it was not necessary to change, and then whoops, suddenly they were late in the game. So I think that's it.
Okay, cool. We have another more technical question from Bart. He says, I know you skipped it intentionally, but I really wonder why it's getting harder to do random sampling. I would guess it's easier today to reach people than it was before. Could you give some of the reasons why it's harder today?
Yeah, I think that there are a couple. Well, one of the important reasons is, and it's a good reason actually, it's privacy. So in the past, you could more or less get a list of all the Belgians all the Belgian households with their addresses and a few things in there. That's illegal now. I think it's a good thing that it's illegal, but makes it harder. Another thing is that in the past, you could come up with some decent samples based on telephone numbers or random dialing, but now with mobile phones, it's all getting more difficult. It's also tied with response, because people are not there or are not refusing. It makes it all very, very, very hard. But I would say that these two are the most important factors.
Okay. And then there's one question from Tim. He's asking, how do you balance using advanced techniques and still having that interpretability, explainability of the technique to the client, because they need to trust the results to be able to interpret them? What do you think?
I'm not really sure I understand the question. Can you maybe rephrase?
Yeah, so Tim is really asking, so you said something about how you were late to the game of deep learning and all of these new and fancy techniques. And he's kind of offering an explanation for that, being that they're less intuitive, less easy to explain to the client.
Oh, yeah.
He's asking, how do you do that right now?
Well, I think two things: by not doing it. Given the fact that we are still very often using, let's say, old school techniques where explainability is part of the game, we are less concerned by it. But you're absolutely right. Some of the new initiatives that Philippe discussed last month, the issue is bigger, and indeed they need to look at things like Lime, like Shapley value, and so on and so forth.
All right. Thank you so much for your talk, Istvan. Another really big virtual applause. I have my other speakers back here. Wait, yeah, let's all applaud together. There, everyone's unmuted. Woohoo! Thanks everyone for being here today for yet another data science meetup. It was a pleasure hosting all of you here today. I hope you enjoyed it as well. And I want to close with my favorite slide this evening, which is, this is the best meetup on earth. If I can, this is the best meetup on earth. Thanks everyone, and we'll see you next month. Bye-bye.
Thank you, Lynn, for hosting.
Yes, thanks.
Thank you. Bye.
See you guys.